6.6, normal distribution. And we've talked about this. We've talked about skewing left, skewing right. We talked about a normal distribution is where the mean and the median are exactly the same. And just as a quick review, we talked about how the normal distribution, whoops, let's try that again with a marker. That the normal distribution looks like this. We have our breakdowns like so. We have 34% here, 34% here, 0.15, 2.35, 13.5. This is just review again. And that's the breakdown. Okay? And we talked about how this is +1, +2, +3, -1, 2, 3. But now, there's going to be times where we're not going to shade just perfectly on the 1, 2s, or 3s. There might be times where we shade something like so. In between 1 and 2 standard deviations away. So we need to be able to deal with this in a different manner. And that's what this table is for. This is the normal table. Okay, so notice your z-scores here. We have -1.4, -1.3 going down this way. And then going across, we have hundreds digits. So this is the number for 1.40 and -1.43, and so forth. This would be the number for -1.63, -1.26, and so forth. Okay? So the z-score table can be used to determine the percent or probability of the population that is below a given z-score or the area under the curve, that this is to the left of the z-score. All right? Always to the left. So, directions. Use the z-table to find the area under the standard curve corresponding to, okay, and then each of these situations. And we're going to draw a picture each time. So, 1. What percent of the population has a z-score less than -1.2? Left of -1.2. So real quickly, it doesn't take very long to do this. You just real quickly make your little bell, and you just draw some lines, all right? And here's -1, here's -2. So where would -1.2 be? Well, something like there. -1.2. And we're going to be going less than that number right there, that spot. I'll do it in a different color. So we're going to shade to the left of that spot. Well, what we do is we go back to our table, and we're going to look up -1.20. Whoops. Let's try that again. Get rid of that line. -1.20. I'll put boxes instead of the circles I did earlier. So that's -11.1. 51, sorry. -11 wow, not working. 0.1151. So -1.20, a z-score of that has an area of 0.1151. Well, to the right, that works out to 11.51%. So about 11.5% would be below -1.2. Now think about it. If we added up this area right here, and we've done this before, we know that adds up to 16%. That's if it was all the way from -1 down. But this is from -1.2. So we have to shave a little bit of that off, and it goes from 16% down to 11.5. Hopefully that's starting to make some sense there. Okay, what percent less than 2.8? So again, we just draw a simple, quick little curve. And we don't have to do both sides. So here's 1, here's 2, here's 3. Where would 2.8 be? It would be right there, 2.8. Now, that means we're going to shade, starting here, all the way over. All right? So we go back to our table, and we're going to look at 2.8, which is 2.80. 0.9974. So again, we're talking about a z-score of 2.8, and that gives us 0.9974. So that's 99.74, almost 3/4%. 99.75% is less than that. Well, again, go back to what we know. We know that if we add up 34 plus 13.5 plus 2.5 plus 50, the whole left side. So again, if we added up 50 plus 34 plus the 13.5 there, and if we went all the way to 2.35, if we add that up, that would be 99.85. But we're starting at 2.8. So a little bit less than that, 99.74 makes total sense. All right, 3, percentage has a score greater than. Now this is tricky. This one's a little tricky. We have an extra step here. So 2.8, but we've already done all the math. Now we're talking about shading this part. So we already have the number here. We've already looked up in point number 2. So for this one, we are going to, and if we want to draw a new one, that is a horrible normal distribution. Let's try it again. And again, we have +1, +2, +3, and here's 2.8. We are talking about going from here, but we're going right now. That's going to be a small amount. Because think about it. Less than 2.8 is 99.74. So all we need to do is 1 minus 0.9974. And that gives us 0.0026. Again, move it over, 0.26%. Not even one, just a little over 1/4 of a percent. Teeny tiny amount. Now, between -1.52 and 1.52. Okay, now in this case, what we're going to do, it always helps again to draw. Pretty bad, but we'll work with it. So here's 1, here's 2, okay, +1, +2, -1, -2. Now, we're talking about -1.52, right about there, and +1.52. So, if we run our numbers, and we find this value, and then we find this value, well, think about it. If I subtract those two amounts, I will find out the overlapping area right in here. Okay? So, we're going to look up -1.52, -1.52, which is right here, and that was 1.52. So that's our 1.52, 0.9357. This sample, this little boo-boo here, actually doesn't have negative 1.5 on it. The full chart will have it. So negative 1.52 would be right here in this spot if it was on the chart. And I'll just tell you what it is. It's 0.0643. So, again, the z-score for negative 1.52 corresponds with the area 0.0643. The z-score for positive 1.52 corresponds with an area of 0.9357. That's what I did make a box on right there. So if I subtract these two numbers, 0.9357 minus 0.0643, I end up with 0.8714, or 87.14%. That's the area in red here, you can see, in between those two lines. Okay? Now, we can also go backwards, as in number 5. Here's our area, 1075. So we're going to go up here and try to find 1075. Boom. Well, it disappeared on me. Let's try that again. 1075 is right here. So what does that correspond to? Negative 1.24. Z equals negative 1.24. All right? On we go. Okay, so to find the probability or percent using the z-table, you may have to convert scores into z-scores with this formula. Okay, so we're going to take x minus our funky u, which is our mean, divided by the standard deviation. So here's where it is translated. Our actual score, our actual value, minus the mean, divided by the standard deviation. So, example 6. Travel time to work in St. Louis has a mean of 38.8 and a standard deviation of 11.3. What percent have a travel time less than 27? Well, we got to figure out our z-score. So we take our actual score minus our mean divided by our standard deviation. And when we do that, we get negative 1.04. So we look at our table. I'm not going to flip back and forth and create motion sickness. We look up negative 1.04 on our table. That yields an area of 0.1492. So that's 14.92% less, okay, than 27 minutes to work. B, what percent of the population have a travel time longer than 50? Well, again, we have to figure out our z-score, so we take our actual value. Now, pay attention, it's longer than. So we have that extra step, which means we're going to do 1 minus our value. And if you have to do that to remind yourself, go ahead. So 50 minus our mean divided by our standard deviation, and that gives us a score of 0.99. On the table, that corresponds with 0.8389. Now, if it said less than 50 minutes, then that would be 83.89%. But we want the right side longer than, so we're going to do 1 minus 0.8389. And that works out to be 0.1611. So 16.11% of the population have a time greater than 50 minutes. So again, if we were asking less than, it'd be 83.89%. That's less. than 50. But 16.11 is greater. Because remember, our table always goes to the left. Now, what about 38.8 and 45? In between. Well, we're going to do two z-scores here. I'm just going to keep doing this to me. Let's see if I can get it to stop doing that. There we go. So z equals 38.8. Remember, that's our actual time, minus 38.8 divided by 11.3. That's going to give us a time of just 0. And our second one is going to be 45 minus 38.8 over our standard deviation of 11.3. And that's going to give us 0.5486. But remember, our table only goes out to 2 digits, so we're going to round that to 0.55. Now, if we go to our table and look at 0.55, again, not the one on the first page, but your actual chart, okay, then that's going to yield an area of 0.7088. And hopefully you can think about 0 as half the chart, right? So that's just going to be 0.5 or 0.5 thousand. So in this case, we subtract these two. 0.7088 minus 0.5, and that gives us 0.2088. Then we convert. That means 20.88%, or about 21% of the population, has a travel time between 38.8 and 45. Next example, standardized test. Mean of 425, standard deviation of 80. What percent scored less than 300? Again, first step, z-score. 300 minus 425, so it's going to be a negative, divided by 80. So we're going to round. It's negative 1.5625, but we're only going out to 100 spot. Now, if we look at our chart, again, that's not on your chart in the notes, but it is on the chart you have in your notebooks. Negative 1.56 corresponds to an area of 0.0594. Of course, you can't, like I said, that's on the other full chart. So, to the right, that's 5.94% less than 300. Okay? What percent scored more than 425? Well, 425, you do our z-score, minus 425 over 80. Shouldn't need a calculator for this one. That's going to be 0 over 80, or 0. Well, you shouldn't need a chart for that one, because 0 is right down the middle, so that means we're talking about 50%. So 50% scored less than, and 50% scored more than, because it's straight down the middle. Now, C, what percent of students scored at most 415? Now, that's the tricky part. You got to think about what at most means. That means they did not do any better. They did up to and including 415, so that means less than or equal. .415. Okay, so that's a tricky one. You got to think about what that means. So we're going to do our z-score here. 415 minus 425. Again, we're going to get a negative, we know. And that gives me a decimal of negative 0.125, which is negative 0.13, rounded, to look on the table, because we had only got the hundredths spot. So if we look at negative 0.13, that yields an area of 0.4483. So we want less than, so that's an area of 44.83%. So 44.8, almost 45% of the population did 415 and below. Now, at least a 430. Well, at least means greater than or equal. So now we do our z-score. We're going to do 430. And remember, at greater than, you might as well write this right now to remind yourself. 430 minus 425 over 80 gives us a decimal of 0.06. On the table, that yields an area of 0.5239. Now, again, 52.39% scored less than 430. Well, we want greater, so we're going to come over here and subtract. And that gives me 0.4761, or 47.61%. Did at least a 430 or better. And now we're bringing it home to the last page. What if we want to go backwards? What if this time we want to solve for x? We know the z-score, but we want to find out what this value is. Very simple. We're just doing basic algebra. So, the speeds of the vehicles, blah, 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 you can read a mean of 67. Standard deviation of 4. And here's my z-score. Right here, here, and here. 3 z-scores. So, we're just going to work backwards. Let's go with 1.96. There's my z-score. 1.96 equals my actual value minus my mean divided by the standard deviation of 4. Now we're just doing basic algebra. How do we get back to x? Well, first thing we need to do is get rid of the 4. Okay? That gives me 7.84 equals x minus 67. If I add 67 to both sides, I end up with 74.84 miles per hour. Let's do it again. This time my z-score is negative 2.33 equals my unknown minus my my mean divided by my standard deviation. First step, again, multiply by 4. That is going to give me, negative 9.32 equals x minus 67. I'm going to add 67 to both sides, and I get 57.68 miles per hour. And last but not least, I have a z-score of 0. Unknown speed minus my mean divided by my standard deviation. Well, this is pretty simple. Multiply both sides by 4. Anything times 4 remains, anything times 0 remains 0. Add 67 to both sides, and so that would be 67 miles per hour. So you just plug the numbers in where they go and work backwards with basic algebra skills. All right. Mean of 75. Standard deviation of 6.5. You must score in the top 5%. Okay, so let's think about that. The top 5%. That's 0.05. That means we're looking for, what is that value right there? So we're looking for an area of 0.9500 on our chart. So if we go to our full chart and find 9,500, now obviously it's going to be on the positive side because we're on the right side. So we're looking for 9,500 on our chart. When you look at 9,500, it's actually not going to be on there. 9,500 would become between 1.65 and 1.66. Technically, it would be 1.655. But I would accept, as long as you show your work, whether you use 1.65 or 1.66. It would not matter. So, we go back and do our math. There's my z-score, and again, you could use 1.66. My actual value minus my mean divided by my standard deviation. Well, I need to multiply both sides by 6.5. When I do that, I get 10.725 equals x minus 75. And when I add 75 to both sides, I get 85.725. So you must score at least 85.725 to be eligible. And then last but not least, the mean is 100.5. Sorry. The mean incubation time fertilized at 100.5 is 21. That's why it's important to read. 100.5 is actually a distractor. And it says the standard deviation is only 1 day. Determine the 17th percentile for an incubation time of fertilized eggs. Well, again, let's look at our picture here. Okay, 17th percentile. So 17th percentile means 0.1700. 71.17, but we're thinking about area, that's going to be this little tiny area here, 0.1700. So we look at our chart for 0.1700. Now we're not going to actually find 1700. The closest we find is 0.1711. And that is for negative 0.96 z-score. So my z-score is negative 0.96. So now we're going to do the same thing we've been doing. My z-score is negative 0.96. My actual value we don't know, minus the mean divided by my standard deviation. Well, that's pretty easy. We multiply both sides by 1. Not a big deal. So basically, we're just adding 21 to negative 0.96. And that will give us an x value of 20.05 days. All right. Now, if you go back to what we learned at the very beginning, this problem is actually a lot easier than it sounds like at first. 95% of our population, remember this is 68%, and this is 95%. 95% of the middle of the population is between minus 2 standard deviations and plus 2 standard deviations. So there you have your two z-scores. Negative 2 equals the amount of days minus 21 divided by 1, which is kind of pointless. And 2 equals x minus 21 divided by 1. So basically we're just adding 21, and we get between 19 to 23 days. And that's it.